Good evening, sir.
Good evening, sir.
Good evening, sir.
Today we'll see wireless lab. All this while you have seen wired lab, right? The physical layer. Be connected with cables. Right? UTP, STP, right? Fiber optics. So advantage in cable is the signal. Ultimately, it is an electromagnetic signal, right? When it travels, it is protected. That is the biggest advantage in cable. Another technology is wireless. So the same electromagnetic signal is converted into a frequency, right? In this, it is in the air. The biggest thing is physics. Whatever you studied in physics, those are all the, so many things you would have studied in physics: reflection, refraction, scattering, absorption. All these things will come in place, right? Because in cable, the protected signal will be there. Here, it's everything will come in place. On top of it, secured. It is in the air. Anybody can interpret, interfere with your signals. And then what frequency I'm going to use? Why? For example, you're using a certain frequency. This is a classic example. When I was studying engineering, let's say this is my engineering college campus. Somewhere here we have our, let's say, hostel. Right? So somewhere here, right, we used to have a police control room. And then police, superintendent of police bungalow used to be there. So why I remember this is, see, I don't know how many of you are actually, know about how this country changed. Prior to 1990, there was nothing in this country. We don't have a proper tape recorder also. Now your generation, you can't live without music or iPads, iPods, or whatever you call them, right? Without those iPods and music, iTunes or Ghana.coms and Spotify's, you can't live without that. I mean, I'm talking about music because you can connect it very well, or these mobile phones. We don't have a phone. We don't have, the rich people can afford phones, no tape recorders. There used to be one brand, National or something, in the, it used to be installed one with all these, you press it, cassette will jump from this, where your cassette player used to be there. What I'm telling is, you want to listen to a new song, you can't. As with Bharati, whatever they give. TV, Doordarshan, weekly once, probably you'll get songs. You may get a new song or not. No. What we used to do is we figured out, at least in my hostel, we figured out Radio Sri Lanka. We used to call it Radio. Sri Lanka is called Ceylon. I don't know how many of you know. Radio Ceylon used to give new songs, very good songs. Then we want to listen to it. How do we listen? We don't have we can't afford radios, most of us. And it was like that. We don't have. So we made our own radio. We went to some car mechanic and we bought a speaker, and then from electronics lab, we took some transistors and all. We made one radio. The whole story is, when we were tuning in, we don't know, we don't have a digital tuner, right? We made it, and then when you're tuning, somewhere we'll catch this. We don't know what frequency also. See, nowadays, my sons, they'll say, Dad, I have a robotics project. You'll be surprised, like everybody's into robotics these days. Man, these days are building robots now. Then it says they'll order a kit from Amazon or somewhere. Everything will be there, instructions, they'll fix it, then there is a robot. There's nothing skill in them actually. Creating a robot, say, I don't know how many of you, it's out of discussion, but once I visited a University of Nuremberg in Germany. My classmate, I went for a holiday. My classmate is a visiting professor there, so I just went there. He's a professor in IIT Delhi, so he visits every year, couple of months there and teach them. So when I was there over a holiday, he was also there. He said, "Hey, come over, let's meet." So I went there, University of Nuremberg. He showed me the mechanical engineering lab where they make cars with their own hands. Even a single nut and bolt, they don't buy. They have to lathe it. Whereas we get news, these engineering college boys made a car. Then what happens? Those guys would have ordered everything. Rich dads would have given lakhs of rupees, and then they just buy them and assemble them. I'm not blaming anyone's system. I'm telling you, if you are in, that's why German engineering is so popular. That's why BMWs and Audis are so expensive. So now the point here is, when you make that thing, we don't have anything. I'm not telling our story here. I mean, it's not to tell about ourselves. When we were tuning, we used to listen this police conversation once in a while. What frequency these police people are using, we don't know. In the process of tuning to get into this radio, we were listening to this police conversation. I was talking about that security. So what frequency you have to use? So it has wireless comes with the package. Security issues, signal issues, which frequency you use. That is why, right till 1997 or so, wireless was not there in terms of data, because nobody has given the permissions to use these things. 1997 actually. Till then, there was no wireless data. Are you understanding? Because of all these issues, right? Actually, wireless, you can go trace back to probably the radio, invention of radio, isn't it? So nowadays, everything is wireless. Every network is a hybrid network now. You have wired network, wireless network. Anyway, this is a wrong diagram at this point. This one, yeah. See, Second World War. This is when actually wireless became very popular. Till then, these old radios used to be there. This radio used to have a license. In India, before 1990, this used to have a license. You can't, not 90, but a little earlier, I guess. My grandfather, I remember, when I was in 6th class, 7th class, every year they have to go to post office and pay the license. So radio you can't have, security reasons. So this, walkie-talkie is a classic example. So when you're tuning into this frequency, if somebody else is there, he can listen. So anyway, what I'm trying to tell you is, in Second World War, only this became very popular actually. But why I took this diagram is, so you can see that oldest military thing. Because in the war, they want arms and ammunition, supplies, and picking up injured people. They need radio. In the forest somewhere, there's no signal. So for radio, for this wireless, what is required? This is where we are getting into the subject now. You need an antenna. You need an antenna. That is, one, the electromagnetic signal is converted to frequency, right? You need a receiver. You need a transmitter. Of course, this is for voice, handset and headset and all that, but you can remove it. So radio compulsorily requires a transmitter, a receiver, and an antenna. These three things are called radio chain, they call it. Radio chain. The exam or something like what is a radio chain? An antenna, a receiver, transmitter. Without that, this won't work. Now, if you see here, basic things, physics you would have studied. Frequency. What is a frequency? English meaning of, what is the English meaning of the word frequency? How frequently you have classes? Every day, weekly 4 days, evening, 8 o'clock to 10 o'clock. So recurrence, frequency is reoccurrence, right? So the signal, right? So this is measured on hertz. There is someone, Robert Hertz, or some German. His name is Hertz. He named it. So if you see a signal, this is a wrong diagram. I only draw it. Otherwise, so this is one cycle. If it repeats, this is another one. Okay. So this one cycle in a second, if one cycle of the signal, that is hertz. 1 hertz. Right? The signal repeats it. Right? Kilohertz. That means in a second, 1000 cycles per second. That is the frequency. Right? Gigahertz. Megahertz, let's say. Megahertz. Megahertz is 1000. Gigahertz is billion times. In a second. Right? Your FM, you listen to FM? FM radio, what is your favorite FM radio channel? Some number?
95, sir. Mirchi, 95.
95. 95 what?
0.0.
95
95.0.
megahertz. Megahertz. That means the radio transmitter, your favorite RJ, will be sending it. The signal from the radio transmitter, it is the frequency of that is 95 million times per second. Then it reaches. That is why they have to pay the money. It's in the air. Right, air is sold, right? Now you know Vodafone, on all these people, they have to pay a lot of money to try. That's why Vodafone is going. Airtel, Vodafone, they're all facing the problems. Why is that? Because they have to pay for it. Air is sold. Air is much more expensive than the real estate. So he has to pay 15-20 crores to get that 95.0 megahertz. Do you understand? So the whole thing is, the more the power, it will go lesser distance. Smaller the power, it will go longer distance. Right? High frequency, lower frequency. Wavelength is, what is the length of this? Okay. Between these two, how much is the length? That is the wavelength. Right? Shorter wavelength will go for smaller distance. Obstructions will be more. Amplitude, again, the height of it. So these are the words you need to know. Generally, the way you calculate. Now 95.0, they're paying the money. For telephone, you're paying the money. For data also, yeah. So that means you have to set up a wireless LAN, you have to pay the money. And in that case, who will pay it? Imagine every network, for your radio at your home, if you want to use it, right? You want to use a wireless, now we are all using wireless now. If you imagine you have to pay extra money for that, then it wouldn't have been popular. Right? So I need something for free. I need some frequencies for free. Then only people will use it. And who will give this frequencies? Right? So US Federal Communication Commission, FCC they call it, like our parliamentary committees, you will have, in US they have Federal Communication Commissions. I mean, federal commissions. For communication, there is a federal, like our parliamentary committee for electronics, parliamentary committee for something else. Like that, India, we have parliamentary committees. So a group of legislators form a committee, they make decisions, they do the research, they'll invite people and they make decisions related to that particular thing. Similarly, US, the Federal Communication Commission, FCC. They make the decisions related to communication. So they gave a couple of bandwidths for free. ISM bands, they call it, industrial and scientific management. That's industrial, scientific and medical frequencies, like ISM they call it. They gave some frequencies for free. Once they gave frequencies for free, then people started using them. Do you know your cardless phones you have at home? Cardless phone?
Earlier we had that.
Nowadays, mobile phone is right. Cardless phone, you know what frequency it uses? Not only that, your what do you call your microwave oven? Do you know that? Microwave, the name itself says, right? Microwave, when you know, have you ever had that? Yesterday's food, you heat it and eat it, right? Now, they just gave me they just gave me some hot water. Probably they would have heated it up in microwave oven. You know, this is heated up. This hot water they just gave me, it is heated up with radio frequency, RF. Do you know that? Couple of frequencies are given for free. So microwave ovens and all use the frequency. I'll come to the figures now. Before going to those figures, what is given for free? So this cable versus Wi-Fi, right? The signal, the frames have to be encoded and signaled, right? So in a media, zeros and ones, but in protection will be there, copper, fiber, you know, all these things. But in wire, in air, see, reflection. It comes here, it is reflected or refracted. Do you understand? Interference, absorption, wood or something, or anything. See, it takes a different thing. Diffraction. When it is passing, it might go like this, or see this. When you're standing, the signal will go. This person you can't see him, right? Because direction, it won't go there. Diffraction. Scattering, right? They say, for example, you have some factory kind of setup, the signals will be scattered. Bank, you have a strong room, right? So here encoding is very easy, isn't it? When you are sending a signal, because 0, 1, 0. Now you imagine, right? 128 or any binary number, let's say any number you take, right? Let's say 140, 128, 64, 32, 16, right? 8, how much? 128 plus 8, 136. 8, 4, 2, 1. Right? This is, let's say 140. Now you sent that number 140. Right? Let's say 1, 0, 0, generally on and off, right? 0, 0, 1, 1, 0, 0. Now this signal went in the air. Okay. Imagine this missed. Now the person received 1, 0, 0, 0, 1, 1, 0, 0. Now this is missing. If it is 0, it is 140. If it is 1, if it is 1, 156. How do I interpret it? One small thing missing here. How do you interpret it? Diffraction, scattering. In a bank, if you see a strong room is there, lot of signals, metal, canton. Right? So what they do is they use something called chipping. Chipping. What they do is, say for example, 0. 0 means they'll send a pattern. They don't send 0 as 0. In wireless, how it goes is 0 means 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, something like that. Some 12 or 11 things will be there. That represents that 0. 1 means 1, 0, 0, 0, 1, 1, or 1, something like this. Now, in this, even if one misses, oh, this is 0. Even if something misses, this is 1. I can interpret. That's how the coding happens here. Here it will not say in a cable, 0 is 0, 1 is 1. But in wireless, they do chipping. It's each one is called a chip. There are different methods of doing, different methods of coding. Encoding is very important. Otherwise, your mobile phones downloads, uploads, nothing is possible in wireless unless and until they use this kind of technology. If you want to go deep into it as a RF engineer, that's a different thing. We, as networking people, that's enough, that knowledge. Right? So now, so this is how the electromagnetic spectrum works. So this, the frequency is 3 hertz to 300 E hertz. I don't know what that, how do you pronounce it? I mean, what is this E? Up to gigahertz we know, right? Terahertz maybe, after that, whatever it is. So this radio frequency spectrum, your mobile phones, AM, FM, your TV, cell phones, they'll be somewhere here below 3, 95, right? 91, whatever, 95 point, whatever, 0. This comes here, 91.1, 94.3. They all kill megahertz, they'll come here. That's where your radio and all these things will come. Do you understand? Right? The radio frequency given by this, underground things will be less, right? See, even electrical AC, electrical power, see, now your cable is going from here, that is radiating electromagnetic frequency. Every cable, now I'm surrounded with cables and all these things. Now each cable which where electromagnetic signal is going, it is generating electromagnetic RF. So this, when it goes somewhere here, it will become visible light. Infrared and ultraviolet, in between what we see the light. So anyway, what we are talking is, right, here, see this, these are the frequencies. 900 megahertz, 2.4 gigahertz, 5 gigahertz. These are the ISM. I took it from cisco.com, this image. You see here, these are given for free. Old cardless phones, 90s cardless phones, old cardless phones will use 900. Now we don't use that. We all use 2.4. Your microwave oven is 2. So this hot water is heated with 2.4 gigahertz. 2.4 gigahertz. Are you understanding? Right? All microwave ovens, cardless phones, now everything is 2.4 gigahertz. That's given for free. Are you understanding? Then, once they gave it for free, say IEEE 802.11. See here, see 1997, they came up with 802.11. See this, these are in different color. The blue color ones are not being used now. We don't use them anymore. But we have backward compatibility. All components can work. Latest component also can work on it. Do you understand? 2.4 gigahertz. See that? Now this bandwidth, I'll just come back on this. Maximum, see, 2 Mbps. By 1997, we have hubs and switches with 10 Mbps and 100 meters distance. But here, it gives only 2 Mbps and 20 meters distance. Right? Hub and switch, 10 Mbps and 2 Mbps. Who will use it? On top of it is very expensive. Why? Because initial days, any electronics goods, I don't know how many of you know the mobile phones initially, how expensive they used to be. Right? So it used to be very expensive, so not very popular, right? Then 11B changed it because it is 11 Mbps. Now we are using 10 Mbps. Then it's good, right? And the distance also increased in it. This changed it. So 99, 2000, those years, all these rich, in the sense 5-star hotels and all those people, they used to use it for customer. They used to charge a lot of money. That's why even now 5-star hotels, they got that habit. They still charge money for the people. So 5-star hotels is the customer sits like attraction. You have a Wi-Fi accessibility. 2000, those were the years. Then 11A is 5 gigahertz. It's mainly used for industrial applications. Not many people used to use it. 11G, it supports both. It gave 54 Mbps. Then it is a revolution. If you see your network laptop card, it'll probably say B/G/N or something. Now currently all your laptops will be B/G/N type of cards. This is the N. What we are using, I am using N now. Right? 54 Mbps. Yes. Now this became old. Why? Because N onwards, right? 600 is a imaginary figure. This is because in 2009, both it uses. It is about why? Because it uses a concept called MIMO or MIMO. Right? Multiple input, multiple output. Input, output. What did I tell you? Every radio receiver, right? They all have this backward compatibility. All of them. Now, I told you, if you have, generally what we will have at home, wireless access points they call. We'll have an antenna, right? I told you, a receiver, transmitter plus antenna makes a radio chain. Makes a radio chain. Okay. Now, this laptop, let's assume, do you know where the laptop has a antenna? Right? Laptop's antenna is this. Here. Now imagine it has a receiver, transmitter, antenna, right? This is, right, one input, one output. That's it. One antenna. Very understand? So when it is transmitted, it can receive, it can transmit only that. See again, wireless, it's like half duplet. It can't be full duplet, right? Because when one antenna I'm receiving, I can't send at the same time. So when actually one guy is receiving, other guy has to wait, actually speaking in wireless. That I'll come there, that point I'll come there. Now this is called one input, one out. Imagine I have one more antenna. These days you see that, right? Multiple antennas. One more antenna. Here actually you will also have one more antenna. Right? If this is 75 Mbps, whatever, close to that they get it. Now if I have 75 plus 75, that means I have 2 radio chains, 2 receivers, 2 transmitters, 2 antennas. Then it will become 150. So 1:1, multiple inputs. 1:2, right? 2:2, 2:3, 3:3, like that. But normally 2, right? 600 you get it if you have 4 radio chains receiving, transmitting. But again, it's the same time it cannot go to multiple systems. Okay, two antennas also will go to one system only at a time. If it has to go to multiple systems, it is called multi-user, multiple input, multiple outputs. MIMO they call it. That is in this latest technologies, these ACs and it's going to come, right? Late 2000 and all these things. That is multiple input and multiple outputs. That's why they say, so this GBs we are talking about. Now in US, they are using it now. In US, they are using it. In India, it's still not come. Still last Month also I took a new connection. They gave me N only. There is no AC in India yet. Otherwise, this is what it is. So there is no laptop in the world today which has 4 radio chains. You have 2. High-end components may have 3. So 3 into 3, maximum you get 200 Mbps, 250 Mbps. That is why, though theoretically it is 600, you get close to 200 plus. If somebody is telling you ACT guy or somebody, I'll give you 200 Mbps, but your component is not ready actually. You understand it? So multiple inputs, multiple outputs. From N onwards, where so maximum you get that 100 Mbps, 150. So each radio chain can up to 75 Mbps. Right? So these are the terms which they ask you in the exam. What is multiple inputs, multiple outputs, radio chains. This is how the concept. Is it clear? Any doubts? Now, if you see here, so just for idea again, see 5 gigahertz will go for shorter distance. So you can see that 5 gigahertz will cover only this much area. Actually 30 meters max. Right? 2.4, 70 meters. So it says 50 and 100, but 30 and 70. See your radio, right? 94 and all that. This is in somewhere in between, say 1 kilometer and all. Then cellular, your mobile phone. See this? 600, 900 megahertz. So anyway, this is just for your idea. Now 5 gigahertz covers only this much. Nowadays, what you do is you have at your home your wireless access point. That's called wireless access point. Wireless access point. There's a dual band. Dual band means what? You can use both 5 and then 2 point. 5 and 2 point. So normally where it is in and around that area, close 5. So when you are streaming your TV, Netflix or Amazon, if you are watching, it should be in this 5 range, then it will be faster. Normal texting, WhatsApp messages, video downloads and all, it will be faster when it is there, within 5. As you go for a longer distance, you just, 2.4, because the signal will not work. Though 5 it shows, it won't work actually. Okay. And again, there is one interesting thing. Now, when you see a wireless signal, say this all of you. When you see a wireless you'll see signal like that, right? Your mobile phone or something like this, right? I like this or something, you will see that, right? So you see that, hey, all the 5 bars are there, all these things are there, but they are not actually the indicator actually, right? So for example, there is wireless access point here. Yeah, wireless access point, they call them. Somebody is here. Your laptop is here, right? On mobile phone is here, let's say, right? And somebody is here. Now this is the maximum range, let's say 2.4 gigahertz. Let's say this is 5 gigahertz range. But this wireless access point, it sends something called management frames, they call them, right? Which they call them beacons also. So this sends it with, see, this is 2.4 gigahertz, okay? This is 5 gigahertz, but it sends these things 1 to 2 Mbps bandwidth. Now what happens now? It will go for longer distance. So this guy, see, actually, you will see the signal. I'll show you this. Light was on. Windows has this application called Wi-Fi Analyzer. I mean, this is a Windows in application. Windows Microsoft Store, you can download it. I did not do anything extra for this. Now I'm not connected though. See, I'm not connected. I'm not using it. See now the signal, whatever it is. So if you want me to connect, see, Mohan says it says because I'm using cable now. So now if you see networks, or so this here, you see 2.4 gigahertz. So this here, 2.4 gigahertz, Mohan's ACT. This is my connection. Mohan's, this is also my connection. Right? You can see all these things. I live in an apartment. People, my friends, my neighbors, people who are, a floor below, floor above, next building. It's a very interesting thing now. If you see here, right? See, I'm in a building here. Okay, I'm somewhere here in this floor. Let's say this is me. Okay. There is a building here, right? If you see here, some connections from here, which are coming from this building, right? Are you understanding? So this is this one. If you see this one, it is five floors below me. This is 5 floors below me. This one, right? See, this one, what it is. This one, this name you see here, that is somewhere here. It is two building. It's a different building. This one, you see, right? So this is couple of floors below me. Are you understanding? This guy is somewhere this side here. So I can see them because it is sending their wireless access point is sending beacons with 1 to 2 Mbps speed. Hey, I'm Mohan's. I can see them. I can see them. See, I'm connected. It shows full bandwidth. But Mohan's ACT, which this is mine. Let's see, actual measure is this. dBm. A decibel milliwatts they'll call. Decibel milliwatts. Right? That is the measure, dBm, decibel milliwatts. This is all false. What you see, those signals, they're all false. Okay, your mobile phone, everywhere, this what you see is not what exactly it is. Because this beacon comes, it says, it shows I have. You sometimes you feel, hey, I have the signal, but I'm not able to download. You have the signal, but you're not able to download because you're just receiving the beacon, the management frame. That's it. Management frame. Right? So you know how this works with the dBm? This is called RSSI. Received signal strength indicator. RSSI, received signal strength indicator. Do you understand? Received signal strength. This one, very interesting. For example, this is your wireless access point. Right? Wireless access points are designed, their power is 100 milliwatts. That's it. Beyond this, it's a crime in US. India, we manipulate, nobody will know it, but no wireless access point is manufactured beyond that. So the antenna power with which it sends signal is 100 milliwatts. Okay. Now this decibel, how it will be is, for example, let's say here you have 100, say your bandwidth is, your frequency is 100, let's say this dBm, let's say, right? That is the maximum, let's say 100 dB. Now when you start going, okay, if this power, it starts reducing, okay, this power starts reducing. Now there will be resistance. So what happens? Your cable resistance will be there, antenna will be there. Antenna will boost the signal actually. Antenna will increase the signal. So there is a gain in power, there is a loss in power. You lose power, I mean, because of wires or any disturbance, there is something called noise floor there. Noise floor. Noise floor is you have your, everything, every disturbance here, all this we learned, right? In fact, interference, your cables, some electromagnetic signal. So your bandwidth is here, there will be noise also. That will decide these things. Okay. So now interestingly, so this, if let's say because of the noise, let's say you say, for example, 3 dBm loss, let's say 3 dBm loss from here to here, 3 milliwatts loss, if let's assume, right, 3 milliwatts loss, the signal strength will be reduced by 2. Say, for example, when it reaches just a few millimeters, if you go a few meters, right, minus 3 milliwatts power, let's say some cable reduced the 3 milliwatts, you will get only 50 dBm. That's it. Are you understanding? If it is minus 10 milliwatts, if it is gone, you will get only 10, minus 10 dB. Are you understanding? So it is, if it is 10 times reduction will be there, logarithmic values actually they reduce. If it is 3 dBm minus means double you will go. 10 means 10 times you will lose. Okay. So the best what you get is somewhere, this is the best what you get, minus, see, we are talking about here, it's a positive 100, minus 40. So every 10 dBm gain means 10 times the power is lost, basically. 10 times. Every 10 dBm loss, not gain, sorry. Loss means 10 times you lost the power. Are you understanding? So if you say 100, then if you see 40, the power from here to here, minus 40 we are talking about. Okay, minus, not the gain. Minus 40 means if it is 90, you lost 10 times the power. If it is 80, 100 times you lost. If it is 70, you lost 1,000 times. If it is 60, 10,000 times you lost power, actually speaking. So from your hall to bedroom, you will lose some 10,000 times, 20,000 times. See, my current dBA is about 60 to 70. You can see. Right? The current dBA is about 60 to 70. Are you understanding? So 60 to 70 is okay. You will get it. Anything above this, you don't get. So most of them, I can't actually have this. Because I'm in a room where I locked it, so because of close the door and all that. So that is why I'm getting less here. My mobile phone still works. I can do WhatsApp. I can see WhatsApp videos and WhatsApp things. All these things will work at say between 60 and 70, which I'm having here. You can see. So your actual measure is this dBms. So if you see, just to give you an idea, if you take this as my house, right? So let's say this is a hall, right? Something like this. If you take, I'm sitting here, somewhere here. I'm sitting here. Right? This is me. Right? Somewhere here. Now the signal, which is now what you are looking at, this is somewhere here. The wireless access point is somewhere here. The signal. So from here to here, hardly how much distance? You can say some 20 feet or 30 feet max. 20 feet, not 30 feet. Right? 30 feet you can take. Right? See, somewhere here, there is another wireless access point that is Mohan. See, that is actually close, but there is a wooden cabinet which is blocking it here. Because of that, say this Mohan is somewhere here. This is somewhere here. And all these things are 2.4 gigahertz. And you remember these numbers. I'm going to explain you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to explain. They're called channels. Right? See, channel 6 is what it is. See, I'm using 6, but the recommendation, see, automatically this app is recommending now 1 is better. I'm using 6 because 6 has more interference. 1 has less interference. So it is asking me if you can shift to 1, you'll get a better. I'm using 6 here. Currently 6 is recommended. So continuously it is changing. This app is recommending it. Right? Now if you see here, this is a live order I'm showing you. See 5 gigahertz if I go, see this? I have 5 dual band, see that? But 5 is, see that? That is what I'm talking about. Right? 2.4 and 5. This is 5. So I can see 2.4, you can see that. Not that these people don't have 2.4. All these people will have dual band. Or at least some of them would have dual band. But their 5 is not shown because 5 will not be shown like this. 5 is closer distance, right? High bandwidth. You can see that. See the curve also. You can see this. What is the width of this? See this? And what is the width of the 5? You can see this. See here there are 44 and 48. There are some of them. Yes, 2.4 is here. 5 is here because 5 can't go longer distance. You can see that clearly, isn't it? 2.4 and 5. So I'm using the dual band. So this is how you actually measure dBms. This is like the best 10. You don't get it at all. If you get between 40 and 50, that means you are sitting next to the router or wireless access point. You get 40 and 50 because the moment the signal travels, again I'm telling you, the moment the signal travels a little 1 feet or so, you will get into negative. Loss of signal, the dBm, as I told you, right? Every milliwatt power, that's right, the double, if 3 milliwatts, 3 dBm loss means double the loss. 10 dBm loss means 10 times. It's like log 2 or log 10, something like that. Logarithms, to represent big numbers, they do. That's how it is. Okay. So that's how you calculate those things. I mean, I'm purposefully not going into that calculation deeply because you don't need that. You can understand this at least, right? That's how it is. Right? So if you want to see that, maybe just see images. See this? You see this image just to show you. See that? Excellent is greater than minus 50 dBm. 50 to 60 is good. Minus 60 to 70, where I am now, it is fair. Anything greater than that is weak. You can see that? I just browsed it just in front. Wi-Fi signals. This is what it is. We call it. So this is good. Right? I'm in this zone now. Minus 50 is good actually. Right? You understand? So yeah, I don't know what website it is. I just picked up that image. It's like that. I'm here. A lot of images like that. See. That's how it is. So that's about RSS. That's about the signal. Any doubts? So you can see this. Let it keep that. This is how you can see it because it sends a management signal, but not RSS, received signal strength indicator. RSSI and dBm. You need to remember that. Right? So now, so this, I told you, right? One radio signal, radio chain, that is one is receiver antenna, one at a time. Because it is in the air, you remember CSMA CD in hub environment, half duplex, one at a time. Right? But collision detection there, here collision avoidance. So if this guy is, because I don't know, right? In a cable, I can detect the collision. Here, I can't. So when this guy wants to communicate, he will send a signal. He'll send a signal and he'll say, hey, are you free, man? That's called request to send. Are you free? Can I talk to you? Then if he is talking to somebody, then he will not reply. So he has to send you clear to send. Then only you can talk. Because it is like we are talking about 54 Mbps or above, so it will be fast. Right? He will do his job, he'll do his job, he'll do his job, he'll do his job, but one at a time. Right? CSMSE, collision avoidance. Request to send, clear to send. Do you understand? When you connect to systems, you can, I mean, this is just for information's sake, it's called ad hoc mode. Right? You can just put them, your network card in an ad hoc mode, and then you can actually send a signal. But what we use in a normal environment here, so this we use, right? Infrastructure mode. We use wireless access. See this? This is hidden antennas. You don't have Cisco's wireless access point. This is Cisco's. You don't hidden antennas. You don't see the antennas. Here, the exposed antennas. See this 4 antennas. That means this has 4 radio chains. Here also 4 will be there, but it is hidden. This is called infrastructure mode. This one, the same thing here. You can see that this is called basic service set, BSS they call it, basic service set. And this area which is covered by this is called basic service area. Basic service area. That's the terminology used. So you all must be knowing, right? SSIDs. Now we have seen that SSID of mine. So this, see here. See, my SSID is Mohan's ACT. SSID is Mohan's ACT. So when I log into both my mobile, I'll say Mohan's ACT will be there. Or Mohan's will be there. Then, okay, that is, I'll click that. Then it will give me, it'll ask me the password or use it, whatever it is. So SSID is human readable. Human readable. By Mohan. And then a normal LAN, in a wired LAN, what happens now? You have a hub or a switch, you connected systems, hub and switch are just facilitating. So you want the communication is always between these two. You send an ARP and ask the MAC address of this guy. But here, I'm talking to this. This guy's MAC address is what I'm asking. Between these two and between these two. So I'll take permission. I want to go to this guy. He will send it to me. Then he will take it. Then he will send it. He will send it to him. So for them to communicate, there is BSS ID, basic service set identification number, which is the MAC address of this guy. It's actually, this is machine readable. So if you see here, see my SSID is Mohan's, but BSS ID, see this MAC address, CCCD something. So SSID is human readable, right? SSID is human readable. BSSID is machine readable. So actually system talks to him. See, I am in that 72 dBm range. Little above fair now. 68 is fair, between 60 and 70, right? Do you understand? See, I'm using what protocol? 11N. You understand? Right? Basic service. Right? The components, the area it covers is basic service area. Right? Now I need to introduce you to this term bandwidth. Where is it? Did I close that? Okay. Disconnected. Now, so this all of you see the bandwidth 20 megahertz. You can see that 20 megahertz. What is that? This is what in our discussion, I said I'll come back later. This bandwidth 20 megahertz, right? So if you see here, this part. This is 20 megahertz. Right? So 2.4 gigahertz, right? That means you see here 2.4002, 2.499 is positive, correct? Now, when this wireless access point, the frequency at what bandwidth it is sending, the signal will be this one, right? This is called a channel, right? These numbers, they're called channels. So when it is sending that frequency, it will send that, right, with 5, right, a megahertz difference, 22 megahertz width, generally, like this, right? So what happens is, first one, second one, third one, fourth one, fifth one. See this is first, right? This is first. Fifth one, this is fifth. Fifth is hitting into the first one. See this? Fifth, fourth, third, second. They all will interfere, right? They all will interfere. And you can see sixth one, first, okay? I can do that here also. First, sixth, 11th, right? First, sixth, and 11th are called non-overlapping channels, right? So if I have an access point in this channel, right, I should have an access point here. If you are extending your LAN, right, this is one. If you don't have this, it will be interfering the signal, basically, right? You can see that, right? So totally you will get 14 channels, but 14th channel is again not allowed. Somewhere here 14th will come. It is not allowed to use. FCC decides it. Federal Communication 14th you can't use. 1, 6, 11 are non-interfering channel when you have a 22 megahertz difference. In the 22, some headers and then some management things will be there, and also 20 is used in N basically. Otherwise 22. Right? These are called channels. You can see these numbers. Okay. Now, if you see here, this I'm using channel 6. You can see 2.437 to 2.447, 27 to 47. You can see that the midpoint is 37. This is the channel I'm using. 20 megahertz. You can see that 20 megahertz. That's what I'm using. This channel number 6, right? You can see this 20 megahertz, the channel, right? So 20 megahertz. See 20 N, 24, and rest of the 20 and 40. So what happens when you have 40 You have bigger bandwidth, your speed. So 5 uses 40 megahertz. Now AC has an option of 80 and 160 also, you can see. So you see this channel, this much space you have, how much signal you can send, this much space you have, how much signal you can send. 20 to 40, double the speed. But you get less number of channels though. Right? See here. If you come here, this is one channel. Let's say channel 1, like that. 6 or so. This is the figure. See that? It starts from 2.402 to then the 27, 37, like that. See, 1, 6, and 11. See, 14th one is not allowed. They have 40 gigahertz. I can have only one channel. Why? The second 40 is cutting into this 14, which is officially not allowed. You can use in India, nobody can. In the US, maybe somebody complains, then it will become a problem. See, I can use only 2. Do you understand? Now, see this, these are the figures. 25 gigahertz, 20 megahertz, you have 24 channels. In US, Europe, and 19, European Union. If it is 40, I'm talking about 5 gigahertz. Why? 22 gigahertz is like this. 5 gigahertz we have seen, right? We still have, or see, this is bigger, right? Now 5, you can see that 5. Where is it? Yeah. See, I'm using channel 153. There it is only up to 13, right? And Mohan is using 153 channel. See, 44 channel. Why is that? I'll show you the figure. See this? These are the channels because he's narrow signals, right? Do you understand? Narrow. So 40 is 80 is 5 and 160 only 2 are possible. Actually, this is just to show you non-overlapping channels in 2.4 is 1, 6, and 11. In 5 gigahertz, 36, 40, 44, 48, these are non-overlapping. That I'm using 153. You can see that 153 is a non-overlapping channel, which Mohan's at my home is using this 153. See, 44 is a non-overlapping channel. My neighbors are using it here. You can see that 44. I'm using 153. Why these are not used? This is a better diagram. So this again, I took it from this website. You can see it here, right? Unlicensed channels, they call them. See, in this, there are some dynamic frequency selection radar things. So these orange colored ones or this yellow color, this part, see from 52 to this, even though he has given it, FCC. Who gives this? Federal Communication Bureau, somewhere it must be written, right? FCC, where? FCC, yeah. Federal Communication Commission. Now, if you see here, these are dynamics. Imagine for radars, military purpose. Now, US everywhere, military station. Now, the military guy is using a radar or something. Every component is designed that it will be continuously looking. Is there any military guy around? Shall I give it to him? So suddenly you will be connected. If you, for example, instead of 44 channel, my neighbor used 52. By default, that his wireless access point will be looking if any priority should be given. If a military guy or a radar something comes, he'll say he'll disconnect this and give it to him. These are dynamic frequencies. So officially they decided in emergencies and war situations, any radar comes, a weather radar comes, and floods and typhoons and whatever they get it. So they said, gosh, we have to give it to them for safety reasons. That is why we use on, though we have about 24 channels here, I use only this 4 and this 5. Rest of them are why unnecessary headache. And 40 gigahertz, I have 11 channels, but I can use only 40 gigahertz. How many? These 2 here and 2 here, 4 only. The rest of them falling in there. 160, not even single channel. 80, 1 channel here, 1 channel here. But official figures, what they are saying, 85 are there, 162. In this one also I can't use. In this 2 I can use max. In this 4 I can use. In this 8 I can use. These are all, so security reasons, they're all controlled. Any doubts? This is how it is. Now, overlapping. If you don't want to overlap, this is called extended service set. This is BSS, basic service set. This is extended service. Imagine your office is so many floors at a 5-star hotel. Here, this floor I kept it in channel 1. Next floor I'll keep it in channel 6. Next floor I'll keep it in channel 11. Next floor I'll again go back to 1. If I want one more here, I can't put it here. Here, if I want, I can put 1. Here I can put 6. So 1, 6, 11, 1. You just make sure they are not there in the individual. So this entire thing is under the same SSID. I can same moments I can put multiple access points or routers which are in multiple channels, non-overlapping channels. Here, see 36, 30, 44, like that I can extend this. Non-overlapping. 5 gigahertz, huh? So this is single one is called BSS. This is called extended service set, ESS. ESS is single point and the components are all in it. Extended service. Any doubts? Right? BSS again. Just to confirm your logic. Are you fine with this?
Yeah, can you please go back to the previous screen?
Yeah.
Okay, sir. Thank you.
BSS, right? So this extended service. Extended service. So if this is in channel 1, I can keep it in channels. Now this is my wireless network. If you go back to this, the beginning somewhere I have this, yeah. So this is called distribution system. Your wireless network, distribution system means wireless network is connected to your wired network. That is distribution system. So it will go to their switch. It's a simple form of diagram that is called distribution system. It's called distribution system. You can see again the same diagram here. The DS stands for distribution system. This distribution system need not go to internet. Here you will have your wired network also, then it goes to internet also. So if I'll show you a better diagram here. So this is how the wireless network architecture. So this is your core layer, you remember? Distribution layer, access layer, then you connect. Autonomous access points, right? Wireless access points. Back there. There are 2 types. One is autonomous access points. Autonomous access points. Another one is lightweight access point. Autonomous access, like any other independent, what you use at home, my home, everywhere, we use autonomous access points. They're independent. You have to configure them independently. Then they will connect the systems, and then that communication is connected to your network. So this is the distribution system. Yes. Then it would have gone to internet or something. Everything like normal routing. Right? So this should have an IP address which should go to this. Then all the systems will go there and work. They're independent. Right? So layer 2 functions, layer 3 functions, this guy is doing. He's, you know, he has a MAC address. I showed you BSS ID, then it'll communicate, it'll come here, it'll authenticate. And then if it has to go to router, it'll send it. Right? So independent. Whereas, see this? These are called lightweight access points. Here, lightweight access, in your syllabus, I think you are supposed to know about lightweight access points. Right? Here, if you see, you don't do anything here. No configuration, nothing. There is wireless LAN controller. See the name itself, wireless LAN controller, WLC. So this controls, say for example, this guy, a laptop, right? You see the SSID. SSID, let's say Mohan's, actually it will be here. They all belong to Mohan's. This guy will, okay, you say that you give password or whatever it is. Now what it will do, it will actually not do anything. It will send it to this guy. Hey, this system wants to join, shall I allow him to join? This guy will say, okay, join. Imagine already 10 systems are there here. Now you don't put many systems, it will become slow. This guy has only 6 systems. This guy says, he's asked me to join. It says, hey, you join this guy. And he tells this guy, you let him have. So this totally control. Right? Only layer 2 functions. So for example, this laptop wants to ping this laptop. Now it won't send it to him. You send it to him, then he will send it to, send it to him, then he will send it to this guy. But they'll go through this cable only. Entire layer 3 functionalities will be done by that guy. He's only just receiving, giving it. Lightweight access. They're all controlled by this wireless access control. You just power on them. You don't do anything. This is called a split MAC technology. Split MAC. So because this guy has SSID, BSSID, that is his MAC address. You're talking to him, but he's actually sending it to him. He also has MAC. So this from here to here, 2 different split MAC. Now what, for him, there are 2 relationships. One relationship with him, between them, is management. He will find out the wireless access point, he'll talk to him, he'll have it, right? Their management. One is for the management purpose. One is for the data purpose. Let's say green one is for the management, the red one is for the data transfer and all the communication. This green one is between only these 2. Green one will not be there here for this. Do you understand? So this is called controlling and provisioning of wireless access point, CAP-WAP tunnel, they'll call it. CAP-WAP, controlling and provisioning of wireless access points. So as soon as we just power on, he will look who is the wireless access guy. And if you have a DHCP server somewhere here in your network, that guy will give the IP address also, but he will build the relationship with this guy. Hey, I want to communicate with you, man. Okay, you are my boss. He has to figure out what. Then otherwise it won't work actually. So, but which system is connected, how the communication is happening, everything is done by this guy. There are 2 tunnels. One tunnel for management, another tunnel. This is a UDP, user datagram protocol tunnel. This is CAP-WAP tunnel, split MAC techno, because this relationship is different. This relationship is different. Whatever he is asking, he will send it. Split MAC technology. Split MAC, 2 tunnels, controlling and provisioning. UDP for control, that is the management, they use UDP 5246, 5247 for data. This is authentication purpose, they use that. You understand? So this may be a question, what is a split MAC, what is a CAP-WAP tunnel? controlling and provision of wireless access points. So this design is called unified wireless LAN controller. That means your distribution system, your network, there is one unified one in your office, so it can take care of all the wireless access points. Based on the location of that wireless access points, the designs will change. This is unified wireless access point. Right? Here, you see this, if it is in a cloud somewhere, wireless access point not in your premises, cloud, he can still control it, as long as there is connectivity here. You can still go and connect with that. A cloud-based or in a data center somewhere. Right? Embedded. So you have small access points within your network which are connected to your access layer or something. That is embedded wireless LAN access. It's a different design. They're all very expensive. Okay, lowest of all is mobility. So this is an access point, wireless access point, as well as controller. I have this in my office. I own this one of them because they are all very expensive. I don't need it for because wireless is recently added to your syllabus. Okay, what I taught you today is the big change in your CCNA syllabus. It was not the earlier just what is wireless we used to talk. Right? Mobility Express. It is a combination. It acts like access point as well as controller also. It can control them. And you will be surprised to see this. If it's a unified access point, which we are talking about, the unified access point in the center location, what the first one which I explained, this is autonomous. Unified access point, the first one which I explained, you can see here, it supports 6,000 access points, wireless LAN control. One controller can control 6,000 access points. The approximate figures though, but 64,000 employees for a large enterprise. One controller can control the entire. Very expensive, that's why I said. And in a cloud-based and data center-based, 3,000 access points about that. So you can see 6,000 divided 64,000 divided by 6,000. It is, we are talking about 10 users per access point. Otherwise, it will become crowded. Same thing, 3,000 and 30,000 is 10 users. Embedded access point is it's a smaller unit, right? I have only 200 access points with 4,000. It's about 20 users per this small campus. It is large enterprises, private cloud. What I have is 100 access points. It can also control 2,000 employees, branch location. Autonomous, you don't need these figures though. It's individual. What we all use at home is autonomous. You understand? So if you see here, one last point, what wireless LAN control can do. Dynamic channel assignment. If you see here, the one which we are doing, right? See, this guy is continuously dynamically, it is telling me channel 6 is fine. Or sometimes channel 1 is better. Recommendation it is giving, right? Wireless access point, you can assign channels. Okay, now this is getting crowded, you move there. This is getting crowded. So which access point and which channel, it's actually dynamically does it. Right? See, now it shifted the recommendation to 1. Now this application is doing the recommendation based on the crowding here. But that can do that. Dynamic channel assignment. Right? Power optimization. I told you, right? It takes 100 milliwatts power. Right? How much is it? Very interesting thing I'll tell you. So this is a very interesting concept. Imagine sometimes you want to download a software update for your mobile phone. You literally keep your phone on the right? You want fast download, you want it. You want to download a movie or you put it on this. It doesn't, because imagine you did that. Now your brother or a sister or your spouse or somebody sitting in a long, far away bedroom somewhere using a WhatsApp video or something. Now this is connected, right? So this guy, to give him, he will send a high power signal. That may be too much for this, because somebody is very far. So this antenna, this access point realizes I have to give it to this guy. And that may be too much for this. So it will see that if this is an access point, there is another access point, it will say, hey, you disconnect this and connect to this. You can do that for optimization and how much power is efficiently used, all that. Self-healing coverage, if this is not working, it can move it to another one. Flexible client roaming, again, the same concept, similar. Small differences though. Client roaming, when you're moving from one place to another place, when you go close to that, you will be shifted to that. Actually, they can do that. Hey, disconnect that guy, connect to the other one. Controller is designed like that. Quick RF monitoring it can do, right? Security management, authentication process. Security tomorrow I'll teach. Wireless security I'll sit separately. It's normal thing, but we'll see it tomorrow. Intrusion protection. What access WAN controller can do, right? Wireless access point, what it can do, right? Or, sorry, what modes it is in? Local mode, which is a normal one. Monitoring, IDS, intrusion detection systems. It can see if anybody is unauthorizedly entering. It can understand the rogue components, right? Flexi Connect. If CAPWAP fails, it still can work like an independent one, right? Sniffer, it can sniff it. Rogue detector, if anybody's rogue system or rogue thing is come, it can detect it. These are all modes. Bridge mode. Bridge mode is interesting. Bridge mode, what do you say? For example, this is your wireless access point. Okay. Now you're connected to wireless LAN controller or something. Now you have a system. All these things are connected, right? Now, if you put it in a bridge mode, you can connect systems with wired on. Wired system will come, then it will become wireless here because this system doesn't have a laptop. So this is in bridge mode. Wired one, it can connect it to wireless network. That's all. Here it is wireless. Here it is wired. That's bridge mode one can. Bridge mode. So both combination, flexi and bridge it can do. Right? Spectrum analyzer, what we are doing the analyzer. So these are the capabilities of access points. Right? So what we learned today is too many things. Right? We learned about differences between wired and wireless networks. What is required? What is a radio chain? Right? What is a frequency? Right? Amplitude, wavelength. There is one more thing, interestingly, let's say phase, they call it. Phase. Phase means what? So for example, signal is this, right? Now two signals in this. So there is one signal like this, one signal like this. Here two signals in the same. They're in the same phase. They're in the, see this 180 degrees difference between them. One signal is like this. Maybe I'll use another color. Do you understand? So one is like this, right? Another one is like this, let's say. So the difference between them, let's say 35 degrees difference. So based on that, whether it is 0 or 1 or 1, 1, 0, 1, 1, the combination, the numbers. So you send, same time how you send multiple data. See now, if you see now currently what we are using, so many components connected, right? Every signal has to be different. So multiple amplitudes, multiple wavelengths, multiple phases, and chipping. I told you chipping, right? Where you put the signals. So that is how the wireless is actually managed. Same time, you will have multiple signals, right? With different phases, different bandwidths, different. wavelengths. They all together, you are able to send so much of data. And because of the chipping, the receiver and sender can understand that even if there is an interference, even if it is far away. So we spoke about these things, and then the spectrum I explained, what bandwidths are given for free, right? So these things. So currently, yes, this is the future. US, they're already using it, but we are using 11N. So the difference I told you, this is 2.4 and 5 dual band, 20 and 40, but here 20, 40, 80 and 160. These are coming up. This is Wi-Fi 6. This is Wi-Fi 5. Till then, there is no names. Now only they are saying Wi-Fi 5 and Wi-Fi 6. Right? So this is not possible because you don't have components unless and until this speed is possible only when you have 8 radio chains, which is not possible. And then they just explained you, right? One system at a time. That's what is one radio chain MIMO, clear to send request. And I spoke about multiple inputs, multiple outputs, and multi-user, multiple input, multiple outputs. Multi-user means same time he can talk to multiple things. That is not possible in 11N. 11 AC onwards it's possible. 11N, same time only one system, one server, one client. And then ad hoc mode, which is just for information. Then this is infrastructure mode, hidden antennas, normal antennas. Then BSS, basic service set. This is how the channels are: 1, 6, 11 non-interfering channels, 20 gigahertz and 20 megahertz and 40 megahertz. This is for 2.4 and this. These are available. And then what are the preferred channels? What are the dynamic and what are used for radars and all? Right? Doppler radar channels and all, whatever FCC located. Then non-overlapping channels, SSID, ESSID distribution system, ESSID, basic set area, basic service set area, distribution system, and then types of designs. The access points, wireless networks. Autonomous access points, lightweight access points with unified thing, CapWeb tunnels, split MAC technology, how it works. Then cloud-based, embedded, Mobility Express, capabilities of wireless access point, and next wireless LAN controllers, and then tomorrow I'll continue this. I have another 20 minutes, but you will not be able to take it, I guess. And that is the reason why I stopped it here. So tomorrow I'll teach how the wireless security works and a small lab on that. We will see. Okay. Any doubts?
Sir, one doubt here.
Yes.
Sir, can you just explain the difference of the overlapping and non-overlapping once again?
You can see that, right? Channel 6 here. So I'm using channel 6, right? This is my channel. You can see, right? Or you take one, channel 1. This is channel 1. This is channel 1. Channel 2 is cutting the channel 1.
Yes.
Channel 3 is cutting it.
Yes.
Channel 4 is cutting it. Channel 5 is also cutting it. Channel 5 is coming here.
Yes.
Right? Channel 4 is coming here. Channel 2 is coming. This is actually 2. 1. This is 2. So this is all overlapping, right? So interference. 6 is non-overlap. 6 and there is a gap between them. Right?
Yes.
Actually, small connection is required when you are roaming, but you can see that, right? Physically.
Yes.
And then 11. 6 is interfered with 7, 8, 9. Everything is cutting 6, but not 11. These are non-overlapping. So you can have an access point here, you can have an access point here, you can have an access.
Okay, sir. Thank you.
That's the same thing which that is live thing. But otherwise, this is where I explain. So this is better. Between them, 5 megahertz difference will be there. This is 20 megahertz difference. So 1, 2, 3, 4. They're cutting each other. Right? So 6 is not, 11 is not. So 1, 6, and 11 are non-overlapping channels. You can put in each access point. See this 1, 6, and 11.
Yes.
These are all images I borrowed from internet. So this is for 5 gigahertz. 5 gigahertz, you will get more.
Correct. 1, 6. Yeah. Okay, sir.
This is how it works. So extended service set means you put 1, 6. See, now 1 will interfere with rest of them. So next to 1, 6 is there, no problem. 11 is there, no problem. Right? Between 11 and 1, 6, 1 is there, no problem. That's how you extend extended service. Otherwise, interference. So imagine you are living in an apartment now. Okay. So you are living in an apartment building. You put in channel 1, your neighbor also in channel 1. There is another neighbor also channel 1. Airtel guy came and he doesn't know, or he just put everything in 1 and left, let's say. You think signal is good, but it's not happening because all these things are interfering with each other. Your microwave oven is also sending some signal. By cordless phone is also sending. Your TV is giving disturbance. Everything, too much of noise, too much of thing. It looks like signal is good, everything is good, but it's not good. Too much of interference. That is when that wireless LAN controller dynamic channel assignment is there, right? So that will help. That will understand that, oh, this is interfering. Let me allocate a different channel. That in a bigger environment, your now latest access points are able to do that. Dynamic assignment.
Okay.
Yeah.
Yeah. Okay, sir.
Future is wireless. Again, like switching, you have to work on this well because you know it, right? How wireless is penetrating into your lives. So,
yes, sir.
I mean, there's no need of me telling you how it is important because that is why Cisco added this to your syllabus in detail. We sent that. Okay. So you guys, whoever is aiming for big, better be careful with this. I gave you more than which is there in your syllabus.
Okay.
Right? Sometimes I teach you CCNP topics.